guys. So, if I needed to find the area of this pie, this cookie, what would I do? I'm going to just write up here so that I can kind of stand in the same place and not write on the cookie. Actually, you know what? I will write on the cookie. Maybe that will make more of an imprint.
Are we going to be eating this?
I don't know. It's possible. Alright, so, how do I find the area? What do I need? I need some measurements, don't I? Why don't we draw a measurement on there?
Radius.
Diameter. Diameter, okay. So, now what? Does this work? Oh, okay. You want it inches or centimeters? Metric or U.S. customary?
Inches.
Inches it is, okay. I'm not going to touch the pie, don't worry. So I'm at 12, 13. All right, stay with me, guys. Stay with me. Surely this is entertaining enough. 13. So you might get to eat it. Just chill. Why would I bring 4 of these if you're not going to eat them?
You brought how many?
So, the area, listen guys, it's fine for you to stay in your groups. Just participate in this for me real quick. What is the area of the circle?
12.3.
You're supposed to know that formula by now. Have you made some flashcards? You should. Area of a circle is, well, hint, what's today? Pi what? Pi times radius squared, okay? And I just told you, that the diameter of this one is 13. So what are we going to do with that?
Square 13.
No, we're not. Anybody else? Cole, did you not get a paper? You got a paper. I got to do what? All right, so good. You have to cut the diameter in half to get the radius, which is half of 13 or 6.5. So pi times 6.5 squared. Now, quick recap, order of operations. What do we do first? Yes. You have to square it first, then the pi comes into play. Hello, I'm Mr. Pi. So we're going to get pi times 40.25. 6.5 squared. Need a little help there. 40.25? 42.25. All right, and then we'll multiply that times pi. Now, your calculators have a pi button built in. It's not an oven, so don't expect it. But your book has been having you round to 3.14, right? All right, awesome. So, when you round that, you multiply by 42.25, what do we get? 132.7?
Yeah.
What are the units? Well, this was 13 inches. This is area, so it has to be what?
Inches squared.
Inches squared. Awesome. So there's 132.7 square inches of hooky for me.
That's a lot of cookie.
That's a lot of cookie. All right. Real quick, though, what if, here's the twist, and then I promise I'll quit taunting you. Here's the twist. What if I only covered that much of it? Okay. So I tried to get that. Just ignore the little gaps. What if, what, do you want me to like spread it around with the... No, okay. What would be the area of the circle that is shaded? What? 1/4. Okay, so let's just write that down really quick. It would be like pi r squared times 1/4. So all we're doing is dividing the area by whatever fraction is related, right? Is it that easy? Do you guys remember what it was called in your book? A piece of a circle. Kind of like a pizza. It's not called a slice. Excellent. Way to remember it.
Piece.
No, it's got a special word.
Right.
It's a section of a circle, so it's called a sector. Sector. Okay. All right. So I'll pause the video. I'll serve some of this. We've already talked about percents. In fact, you've been talking about percent since at least the 5th grade. Okay. You do more in-depth problems in the 6th grade, and then some of you are in 7th, some of you are in 8th. So you might have one more year experience than the person beside you. But we're going to take a look at how does it change? Does it change a whole lot when we deal with percents that are greater than 110? And that's why I gave you the problem about everybody in the media giving an interview. I'm going to give 110%. Are you? Are you going to add a third arm? Or, 7 toes extra? 110% is a fallacy. Let's call it that. Okay? Unless you take like steroids or something. Okay. Maybe they should look into that. Opposites, it's pretty self-explanatory. I've actually used that terminology before. So opposites is just being able to work on the number line and understand the opposite position relative to 0. Okay? Or the opposite side of the fence, I guess. If you have like an evil twin on the other side of the fence. You guys ever imagine that? Just me. Simplifying more difficult notations. Don't look at that. Don't let them skew your opinion of simplifying more notations. Just call it that. Simplifying more notations. Now, is this something that we've done before when we change everything to addition? Yes, that was a previous lesson. That was exactly how it started here. Make sure I get through that. And then we change everything to addition. And what that allowed us to do was separate people into teams. People, or I should say numbers. You're more than a number here, though. So, all right. So, instead of saying minus 4 here, that's still just going to be negative 4. It just happens to be in parentheses. It kind of separates it. Or likewise over here, instead of minus 5, we change that to plus negative 5. So, it's not something you haven't done before. They're just going to give you problems that are a little bit more complicated. Now, when we look at something like with the brackets. Now, why did we have to use brackets? If you look at 79.2. What? Wow, that's a lot of brackets. What? Why? Well, if you look, the brackets are already around an existing set of parentheses. So the way we do this, we'd work from the inside out. Where would that rule come from? Working from the inside out. Is there an order to doing things that we've learned about?
Order of operations.
Yeah, order of operations. Which starts with what?
Parentheses.
Yeah. So what's inside the parentheses is what you start with, and you simply work your way outside of the parentheses. That's kind of what's going to happen here when you have the negative 2 in this parentheses and you work your way out. What would happen there to just the minus and then the negative 2? The two negatives get together, have a positive party. But then it turns out we're going to subtract that anyway. So there's all this kind of redundancy with all of these negatives. They're going to end up canceling each other out. So let's take a look at what it was and what it converted to. So minus negative 3 turns into just a 3, also known as positive 3. Minus the opposite of negative 2. Well, if we change the opposite of negative 2 to just 2, that will turn into minus 2, or just plus negative 2. Same thing's going to happen. No, that's a different problem, sorry. So, minus negative 3, the two negatives get together, turn into a plus sign. So once you convert, you get rid of any double negatives, which you're not supposed to do in English anyway, are you? Can't, never, could? Yeah, I've heard that before, right? Okay. Doesn't sound like you're very excited. I thought you'd be more awake after some chocolate cookie stuff. Turns out I had the opposite effect. All that to say this, less than 79 is just an extension of what we've already been doing. Okay, it's nothing new. And then increases in percent. So this is the one that, if you had to pick out of the four, this is the newest and maybe the most different. So let's stop. Let's camp here for just a second. Increases in percent. When they use funny units, it's always kind of interesting to me. kind of difficult to follow, to be honest. But why don't we make it a little more mainstream, at least for us in our age group? I guess I'm grouping myself with you. So the baseball team had their first game, right? Well, they already had their second. I want to go back to their first one, which was just a scrimmage, right? You guys remember what the score was? Was it 15 to 20? 15 to 20. So it's always nice to compare, be able to. That's one of the best parts about percent verbiage, to be able to compare values and make statements of summaries. So the winning team scored what percent more than the losing team? So 20 is the same thing as 15 plus a percentage. Said another way, 15 increased by what percent is 20? So that's the type of problem we're going to be able to answer when we look at this. An increase in percent. I'm going to decrease in percent could work the same way. But I need you to follow along with that example for a second. 15 increased by what percent produces 20? 5%? Just be 5 runs. I'm looking for a percentage. 15 increased by what percent? Let's get a little paper here. There's one. 15. All right, so let me set this up for us. So the score was 15 to 20. Okay. So 15, if I just restate what I said, by what percent is 20? So this can be kind of confusing for students because they don't know, are they going to do work with the 15 or with the 20 or both, and then what order? And that has to do with a misunderstanding of percents and also grammatical arguments. Like, well, what order did you say the words in? But 15 is increased by a percentage to get 20. Now, when you increase by a percentage, there's 2 ways to think about it. It's 2 operations. You have choice.
What multiplication be then?
Multiplication would be one. The other one would be addition. But addition would not only apply. It would have to actually be a combination of the 2. So here's where the meat of this question lies. What do I find a percent of? $15 or $20?
You do 15, wouldn't you?
Okay, why? Why do you think you do 15?
Because it says 15 increased by like a certain percent.
Alright, so it was a percentage of 15 that was what? Done, something was done with that to get to the 20.
Right.
What was done?
It increased, so it went up.
What operation am I thinking here?
Multiplication.
Be added here. So we're going to multiply first and then we're going to add. So did everybody follow along with what Jeffrey said, that we're going to take a percentage of 15? Or be dealing with that. First of all, there's a number, there's an elephant in the room, a number that's happening between 15 and 20. Isn't there? It's not really an elephant, come on. 5. Is it safe to say it increased by 5 runs? Yeah, okay. So here's what we're thinking. 15 is increased by a certain percentage to get 20. That percentage comes from the difference between 20 and 15, which is 5. So here's the first question we have to answer. 5 is what percent of, and here's where Jeffrey's answer comes into play. You have to know if you're taking 5 as a percent of 15 or 20. And it all has to do with the way the question was stated. 15 is increased by what percent to get 20? 5 is what percent of 15? It's really close to that. You should, yes. We're going to round. 33%. It's technically 33.3 repeating. So 5 was the answer we had to pull out as the difference between the start and finish numbers. 15 was increased by 33% to get to 20. Now, so that's the answer. We had, the first part of the question was, what amount was the change? And then that amount is the percentage of which figure, the 15 or the 20. And because it was written this way, we knew we had to do it with 15. Now, let me ask you something. What if I reverse the order of that? This is my clarifying question. $20 is decreased by what percent to get 15? Is that automatically the same? Or is something going on here?
We're dealing with the opposite operation.
Am I? Just opposite operation? It is the opposite order. I'm going from 20 to 15 now, and I'm saying 20 is decreased by what percent to get 15?
So instead of doing add, addition, multiplication, you're doing subtraction, division.
Tell me how to do it. I think what you said was halfway right. Half of that was right. Otherwise known as 50%. No, but really, do you guys think this one's also going to be 33% because it's the same two numbers and it's the same amount? It's 5? Is 5 run difference? Right? Wrong. I don't know. Tell me. Think a little bit. You'll get out of here in 7 minutes. It's going to be an awkward silence on the video. I feel like we should play some Simon and Garfunkel to go along with it. If you look at the order here, 15 to 20, 15 was the starting amount. So the percentage change is applied to the starting amount in the problem. So that's why English and the grammar, the order of the words matters. Not so much grammar, but the order of the words. So to go from 20 to 15, 20 is the start. 20 is the one that's going to gain or lose a percentage of itself. 15 is just the outcome. Okay? Am I making any sense here by talking about the starting value and then the outcome? The starting value is what the percentage change is applied to. So, 20 is decreased by what percent to get 15? Well, first off, how far is it from 20 to 15? It's still 5, but now 5 out of 20 is what percent? 25. So let's pay attention to the difference in these two statements to kind of make sure we're on the same wavelength. In this first problem, 15 was the starting amount. The percentage change was applied to the starting amount 15. So that's why it was 33%. Whereas in the second problem, I started at 20 and I worked down. So it was a decrease in percentage. I had to think 5 is what percent of the starting amount? 20. So let's make these let's make some statements here. 20 is 33% more than 15. So again, think about I'm starting with the 15. I'm applying the percentage change. I can say 15 is 25% less than 20. One final thing that goes back to the percentages that are greater than 100. Greater than 100. So if I come up here and I try to say 20 is 33% more than 15, well, what's 100% of 15? Don't overthink it.
15.
Yeah. So if I add 33% to 100%, what is that?
133.
133%. Or, what is that as a number? 1.33. You see, anytime you're dealing with percentages that are greater than 100, the multiplier is over 1. So look at that number here. 1.33 is 33% more than 100%. So that's all you do for percentages over 100. Yes, you add to 100% whatever value is that difference. Contrast that here. Now this is not going to be a percentage over 100, but it says 25% less than 20. 15 is. What decimal value represents 25% less than 100%? Okay, let me ask that in two simpler questions. What's 25% below 100%?
25%.
What's 100%? Take away 25%.
75.
75. What is that as a number? 0.75 or 3/4. Now wait a minute. Are y'all just doing that because you think it's time to go? I'm pretty sure it's 9:22.
So how long do we have left?
3 minutes, which represents 1/20th of an hour, or 5%. 5% of class time remains. See what I did there? So, here. When you have percentages that are more than 100, you simply add whatever it is more than 100. Take that another way, okay? One last clarifying question. What's the difference in doubling something and giving a greater percentage of yourself, or whatever it is? Huh? You're adding? Or let me say that another. I asked that really strangely. What's the difference in doubling and adding 100%?
Well, if you double something, you're
What? It's the same. Oh, that's a novel idea. All right, Peyton, so if you start with 4 eggs and you double it, you'd have how many? 8 eggs. Everybody agree on that? She doubled 4. If you start with 4 eggs, what's 100% of 4 eggs? And if you added 4 more eggs, oh, he's got it. Does anybody else understand that? When you double something, you add 100% of itself. That should help. Work on those tomorrow. I'll post a solution video for you to go over.